Here this morning, welcome. We are on page 360. We're still in activity 1. We've got more of these cases of the intercepted arc to think about. In the previous video, long one I know, we'll see how long this one goes, but we want to get to the point on this one. That video, the intercepted arc was created with one of our lines that went through the diameter. In this video, we're going to talk about two cases, the remaining two, where in one of them, the center of the circle is actually on the interior of the inscribed angle. And then this one, the center of the circle is on the exterior, not in between the points. Let's get to it. I went ahead and I knew that at some point I was going to have to also wanted to create my note card for the inscribed angle theorem, which is what this video is about, finishing the three cases. We have to explore all three cases because not everything applies evenly or equally in the same manner. We want to make sure that we have covered all of our facts, all of our reasons and resources. But there's still some similarity, so let's see what we can come up with. Remember, all radii of a circle are going to be congruent. So these auxiliary lines that we're drawing from the center of the circle are actually creating isosceles triangles because base angles of isosceles triangles will be the same. So I can insert in the base angles of this top isosceles triangle some x's, and I can insert some y's into the base angles of the other isosceles triangle that was created. This one OPT and this one MOP, MOP. Okay, when you look at angle TOP, this one down here, it's the third angle of that triangle, and being the third angle, all three of those angles have to add up to 180. It also forms a linear pair with the diameter that's drawn, and therefore, because of the exterior angles of a triangle, we get to say that that exterior angle is going to be those two added together. We'll call it 2y. Let me zoom in on this for a minute. All right. Now, that same logic applies where these two angles are the remote interior angles of the triangle. So when you add them together, they would make all three angles add up to 180. But this angle is a linear pair with the outside. So the exterior angle here, exterior angle, is going to be what you get from adding the x's together. So those two x's create 2x. Those two y's create 2y. Okay, now what we can do is we can say that 2x plus 2y. That's what you get from adding up angle MOR and angle MOT, or ROT. Angle MOR and angle ROT add up to 2x plus 2y, and they are, in fact, angle MOT. This is the measure of angle MOT because you added them all up together. Okay. They both have a 2 in them, right? So I'm going to put an equal sign here. Equals angle MOT. They have a 2 in them. And so since they have a 2 in them, we can use the division property to divide by 2. The 2's will cancel. There's technically a factor step, and then after you factor, you divide by 2, where you divide evenly everything divided by 2. But look up here. This is angle X. And there's an X. And in our proof that we did in the previous video, we used, boom, substitution property to say that if X shows up, the angle that gave us X will also be able to substitute in there. So I'm going to replace this X with this angle, and that is angle MPR. Angle MPR. And then the same reason says that I can replace y with that letter y, but that letter y is on this angle, RPT. So therefore, what that means is that 1/2 of the measure of angle MOT is there. Oh, check this out. Let's go back and look at the diagram. Look at the diagram here, right? Here goes. So in the diagram, angle MPR and angle RPT, those two angles are added together through angle addition, and they make this bigger one, MPT. So these two together are being added to make the measure of angle MPT. Angle addition is all that is, right? It's just adding two angles together. These two angles are small, but when you put them together, they make the bigger angle, angle MPT. It's still 1/2 the measure of angle MOT. One more step to make. Again, this is not about the angle that's created. It is, in fact, about the inscribed angle being half of the intercepted arc, right? So we want to find the intercepted arc. We want to know what we're referencing here. And in this case, the intercepted arc is MT. But that intercepted arc is the same as the central angle. And so since the intercepted arc is equal to the measure of the central angle, angle MOT is a central angle. So we get to just swap it out once again using our PAL substitution to say that angle MPT equals half the measure of arc MT. And that is our proof. Case 2. Yes, it doesn't have the same rigid proof. Make sure you haven't made, assessments or assumptions. But we did it. Let's take a look at case 3. All right, so we proved 2 cases, essentially. We've said in both of those cases that the inscribed angle is equal to half of the intercepted arc. That's the goal. That's what we're looking for in order to have a theorem. We want to cover all of our bases. So we can say now, from this point on, that half measurement. It's actually up on our word wall. Okay, up on our proofs. We have it over here too. Okay, case 3. So in this case, the center of the circle is on the outside, but it still creates isosceles triangles when you look at the radii. So like radius OR, radius OM, radius OT, radius OP. This is an overpowered problem. Now, in this picture, what we're going to do is we're going to cleverly label the base angles of the isosceles triangle. Let's focus on this one first. Okay, let's focus on the triangle created with OPT. Okay, now we're going to say that, careful here, this whole shape, that whole angle right there, and so I'm going to use one thing, I'm going to put my letter to it over on the side, that is X. And then that means that in this triangle, all of this is also X. That means this exterior angle is what you get from adding both of those together. This angle is 2x. Oh, this is really like layers of annoying. Sorry, you heard that said on video. This angle down here, we're going to call it y. Okay, so I've got layers upon layers of isosceles triangles. I have this isosceles triangle, and now I'm looking at the super thin little one right here. Let me zoom in, all right? I'm now looking at the isosceles triangle that's right here, super teeny tiny. All right, I'm looking at that isosceles triangle, and it's also base angles are congruent. And since base angles are congruent and you add everything up, this exterior angle, it's so minuscule. That little exterior angle is going to be the double y that we're looking for. Okay, since that's 2y, again, I got layers upon layers of annoying. This is 2y. Since these are both x's and this is 2x, then that means that all of this is the same central angle. So this is also 2x. Intercepted arc is the same as the central angle. Okay, we're going to do a little bit of magic here, right? The goal is to produce the measurement of MT. That's our inscribed angle that we want to talk about. So in order for us to talk about that inscribed angle, I'm going to set up like a little bit of an equation. I'm going to say that, let me zoom out for a minute. Put that right up there. Okay, I'm going to say this. I'm going to say that arc MT is equal to this whole thing. So this whole thing is 2x. But I got to take away that little arc right there, 2y. That I would not expect you to do on your own. If you do see it right away, revel in your mathematical savantness. You are doing amazingly. But if you didn't see it and you're still here watching the video, thank you for watching the video. In this moment, 2x minus 2y, that happens because all of this arc from R to T, and we're taking off RM. Like that's what we're doing to get 2x minus 2y. We want the leftovers. Green is the leftovers. All of it would be the 2x because it's all of this exterior angle. Take away the amount that we have. Okay, factor and divide by 2, right? So I'm going to divide by 2, which means I can put 1/2 the measure of MT, and it's going to equal x minus y. Oh yeah, that's not too bad. All right, yeah. Now, wait. Okay. So this is getting. I'm picking up more what's supposed to be said. X is all of this, right? X goes from OP to PT, this angle, but we want the inscribed angle, and the inscribed angle goes from M to P to T. So it's just that little sliver. It's not all of the orange angle. It's the tiny little bit when you take away y. So we can say that x, which is RPT, take away y, which is RPM, rotations per minute, and that's going to give us the leftovers. This is going to equal MP to T, because if you have all of the angle, that's RPT, and then you take away the little bit of the angle, RPM, whatever you have left, which in this case is MPT, all of this becomes MPT. The leftovers is what you got from angle subtraction, and it's going to equal half of the intercepted arc. So therefore, putting these two statements together, half of the measure of the intercepted arc is going to equal the measure of the angle MPT, and there again is our proof. We work hard for proofs. They do not happen easily. They do not happen with novice experience. You have to put in the time or listen to an expert in order for it to start to make sense. And you got to do your practice. Have your note cards made. Add to the back of your note cards the statement, the diagram, examples to fill it out so that as you work through these and you come across more and more detailed information, you can continue to build upon your knowledge. This is our leavings for the video. Let's go to the last part right here. Because you proved that the relationship is true, you can now refer to it as a theorem. The theorem is the inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. Before we leave and go on, I do want to, like in the video, I do want to acknowledge this. The converse, okay, it said something like this. If you have an inscribed angle, then it is half the measure of the intercepted arc. So the flip of it would be something that says something like this. An intercepted arc, okay, is double, half versus double, right? That's the flip when we talk converse. An intercepted arc is double the measure of the inscribed angle. And is this always true? Yes. Okay, because if you know the measure of the arc, then you know the measure of the inscribed angle. If the measure of the arc is known, then you can find the measure of the inscribed angle. All right. Again, thank you for watching this video and for sticking with all of the details, the braininess of this page. Yes, there's more in this activity that we need to cover, and we'll get there. Click on the next video, like, comment, and subscribe, and we'll see you in the next video for continuing your math journey. Thanks so much. Have a good day. See you later.